Welcome back to the stream, everyone. Today we are going to learn about some JavaScript inheritance using their class hierarchy. Last time we did an homage to Space Invaders. It was actually pretty fun, game dev, where we programmed in some pellets to generate from a character to shoot these bugs that we had dropping down from the sky. If you want to check that out, it's on Twitch, and once it expires on Twitch, it'll be on YouTube. Also, if you want to check out the rest of this series, go to YouTube, Noctophonics, and you'll be able to watch it from the beginning. So for today, let's jump into JavaScript classes. All right, JavaScript is an object-oriented programming language, and an OOP language. We're programming with an OOP. We can use to model real-world items. In this lesson, you will learn how to make classes. Classes are a tool that developers use to quickly produce similar objects. Take, for example, an object representing a dog named Hallie. This dog's name, a key, is Hallie, a value, and has a behavior, another key of 0. This is the way that they've set this up, is tripping up on that. So it's the name is a key, the Hallie is the value, or Haley, I think that's just Hallie. Behavior is another key with 0 as its value. Then we create the Hallie object below. So we've seen this before. This is just simply creating an object. The underscores here simply mean that we don't intend to directly edit those properties, but we will reference them and then change them with the getters or not change them with the getters, but use the getters to get them and then change them. But now imagine if you own a dog daycare and you want to create a catalog of all the dogs who belong to the daycare. Instead of using the syntax above for every dog that joins the daycare, we can create a dog class that serves as a template for creating new dog objects. For each new dog, you can provide a value for their name. We've seen this once before, but I don't think we fully understood what classes were. So as you can see, classes are a great way to reduce duplicate code and debugging time. After we lay the foundation of classes in the first few exercises, we will introduce inheritance and static methods, two features that will make your code more efficient and meaningful. All right, let's get started. So in the next exercise, you will learn about classes in greater detail. Before you do, take a moment to study the class that we currently have in main.js. Okay, so we have a keyword here first, just class. Then we have whatever we want to name it. In this case, it's dog. Then it looks like they're creating an object of sorts with a function. Let's see, so they have a method inside of here called constructor, the property. That property returns, or I guess it creates the properties of name and behavior with inputs that you put here. So name would be just whatever you pass through that method, and then behavior would be 0 to start. They have a couple getters, which just tells us that tells us what those properties are, and then another method here called increment behavior that will, well, increment the behavior, just increase that by 1 after it's set to 0. Okay, pretty self-explanatory. Now let's unpack this a bit. So copy the class instantiation method call and console log the statements below to main.js. Okay, so they want to create a new dog. At this point, they're just showing us like how it works and not dissecting it. They will in the next few exercises. So we want to create a new dog. I'm just going to copy the code that's here without fully explaining it at this point. But this is just the syntax that you need to create a new type of this class. So with the keyword of new, dog, and then put in your name there. We want to console log the name and the behavior. So console log. And honestly, from this point, you probably can understand all that you need to know about the structure of it, and then at least for a simple class, and then we'll work on building inheritance with multiple subclasses and all of that. All right, so we're going to console log the name. We also want to console log the behavior. Hallie.behavior. Hallie increment behavior. This is calling on the method that was built into the class, increment behavior. Console log the name. This is going to be Hallie.name. And then the behavior again. Okay, so we console log the name of the behavior at first, and then we run that method that increments the behavior, and then we console log the same properties again to see the change. And there we go. So this name was fed through the constructor function here, and that became the name property. This behavior was incremented. It was at first 0, but then it became 1 after we used the increment behavior method. But as you can see, the constructor, this runs automatically essentially. As soon as you declare a new object within the class, this function runs. So that constructor method runs. And the way that we start that is by using this keyword new. It basically says that, okay, we're creating something within this class. We're going to use the constructor to create this new thing. And then dog is just the class that we wanted to specify. And then the argument here is fed into the argument of the constructor. Pretty easy to unpack that, but they'll go step by step in a second. All right, so for the constructor, in the last exercise you created a class called dog and used it to produce a dog object. Well, we didn't create the class, you guys did, but we'll do it now. Although you may see similarities between class and object syntax, there is one more important method that sets them apart. It's called the constructor method. JavaScript calls the constructor method every time it creates a new instance of a class. So that's what those are called whenever you're creating a new object within a class. It's an instance. So they're showing us again how they set it up. By convention, we capitalize and Pascal case class names, meaning that every word is capitalized, even the first one. Whereas camel case, you don't capitalize the first one. JavaScript will invoke the constructor method every time we create a new instance of our dog class. This constructor method accepts one argument, name, and inside of the constructor method, we use the this keyword. In the context of a class, this refers to an instance of that class. In the dog class, we use this to set the value of the dog's instance name property to the name argument. So in less words or in fewer words, like we said before, whatever name you declare at when you're instantiating, creating a new instance of the class, whatever name you put in there is fed through the constructor function. Under this, we create a property called behavior, which will keep track of the number of times the dog misbehaves. The behavior property is always initialized to 0. All right, so let's create something from scratch here. So we're going to create an empty class called surgeon. So just type in the keyword class and surgeon capitalized, like so. This is going to be, I don't know, I did not see if they had yeah, you don't actually need an equal sign for this. All you need is the braces there. So we'll go ahead and put those in class of surgeon. Inside this, we're going to create a constructor that accepts 2 parameters, name and department. So just type constructor. This is going to have 2 parameters, name and department. Within this, we also want to create it like an object, or like just have a code block at the end here. Inside of the surgeon constructor, create name and department properties and set them equal to your input parameters. So with these property declarations, we put in this, and then this dot whatever we want the property name to be. So this, we're going to put an underscore because we don't want to directly change these things. That doesn't do anything as far as like functionality. It just tells the programmer that we're not intending to change these directly. So this dot name equals name. I believe these are separated by semicolons instead of commas. That's another difference between the class construction and, or well, I guess this is a method inside of that, so there's no difference there. I was thinking of it like an object, but yeah, just like in any function, you want to separate the lines by semicolons. So then we have this dot department equals department. Okay, easy enough. Okay, so instance. Now we're ready to create class instances. An instance is an object that contains the property names and methods of a class, but with unique property values. So let's look at our dog example. So this is what we did in the first module, where we create a new dog with that new keyword there and declare the class. So for our surgeon, let's create an instance of the surgeon class, set the name to Francisco Romero and department to cardiovascular. So underneath our class, we're going to save this to a constant variable called surgeon Romero. And then we have our new keyword, we have our class name, and then in the parenthetical, we're going to put in, for the two arguments, first Francisco Romero, and then the department. So separate these by commas. The department is going to be cardiovascular. Vascular, there we go. Okay. But wait a second. Did you pass in Francisco Romero as the first argument in surgeon? Francisco, there we go. Nope. Romero, oh, I put in an S instead of a C. Francisco, there we go. All right, create an instance of the surgeon class. Set the name to Ruth, Jackson, and department to orthopedics. All right, so we're just going to create another one here, another instance of our class. So constant surgeon Jackson. This will equal new surgeon. So just another instance of our class. The name is going to be Ruth Jackson. And then the department is going to be orthopedics. Okay. Methods. At this point, we have a dog class that spins up objects with name and behavior properties. Below, we'll add getters and a method to bring our class to life. Class method and getter syntax is the same as it is for objects, except you cannot include commas between methods. Okay, so in the classes, you don't put anything after the curly braces. You just leave them as they are, because they aren't like separate properties. They're just like different methods, different functions. Okay. So they added some getter methods to return the name and behavior, and then incremented behavior. So we're going to do something like that with our surgeon class. So within the surgeon constructor, prepend the name and department properties with an underscore. Okay, we did this before, but in this example, they didn't give us those. So we're going to have those added in. And then add a property named remaining vacation days. So this underscore remaining vacation days. And set that it equal to 20. Okay. Under the constructor, create a getter called name that returns the value saved to name. Okay, so we just get called name. So get name. This is then going to have this. It's going to return this value, right? So we need the return keyword of this underscore name. Believe that's okay. And let me check the syntax of, we do need a pair of parentheses here, but when we're calling the getters, we don't need to add those. That's only when we have a method we're working with. So with the getters, we do still need, when we're declaring them, we still need those parentheses, just in case we wanted to put any parameters within the getter itself. And then we need to include this for the department as well, but we'll do that in the next step. So get department, put in those parentheses and braces, and then we're going to return, I have two pairs of those. Then we're going to return this dot department underscore department. Okay, under the department getter, create a getter called remaining vacation days. Okay, so then on the third one, for the third property, remaining vacation days. And notice we've done this before, but just notice that with the getters, we remove the underscores, but keep the same name. And that also, the underscores help in that way too, where you can name your getters or methods the same name, just without the underscore at the beginning, so you can keep everything straight, everything looking, or everything looking cohesive inside of the code. Creates better readability. So let's return this dot underscore remaining vacation days. Okay. Then under remaining vacation days getter, create a method called take vacation days that accepts one argument named days off. Okay. So go ahead and add that here. With this, when you declare methods inside of like objects like this, or yeah, when you declare them inside of objects, just say take vacation days. Then we have one argument of days off. Set up just like the getters, except we don't have that keyword get. And then when we call these, we want to include those parentheses. And we need to set this to the result of subtracting days off from the number saved to the vacation days. So this dot remaining vacation days minus days off. Okay, and with these two, with the methods, you don't need the return keyword because this is just, it's operating like a function, so it will run this this line and then not return anything. If you wanted it to, you could return that value, but you don't need to since you've already set up your getters. So we'd call this method and then have a getter to show us the result of that method. But take vacation days, I think I input and subtracts it from the remaining vacation days property. This is remaining vacation days to 20, right? Now let me see if I spelled everything correctly. Something is off here. Days off this. Let me check the syntax as well. Minus this dot remaining vacation days. Looks correct. Let me make sure that this is the same. Okay. And give me one moment. My mouse has just died, so I need to reconnect it. All right. Okay, back in business. So I'm not sure what I'm missing here because we have the method set up correctly with the correct syntax. There's no comma separating anything, but when we run it, CodeCademy does not see it as correct. So inside of this method, we subtract days off from the number of saved to remaining vacation days, which we have set there. Does this need a return? Hold on, maybe no, it doesn't need a return. Oh, set remaining vacation days to the result. Okay, so we need to reset that. Instead of just running the operation, we also need to reset the property. Remaining vacation days. And then this, but what we can do is just a minus equals, right? Instead of typing it out twice, we can just do minus equals days off. Just like that. Okay. Method calls. Finally, let's use our new methods to access and manipulate data from dog instances. So they're still referencing the dog class here. Let's see, so showing us how they called the method like we did in the first exercise. So with our surgeon constructor, or surgeon class, let's see how we can do this with our vacation days. So at the bottom of this, let's print out the value saved to the surgeon Romero object. So we've got our instantiation, creation of our instance down here for surgeon Romero, and now we're going to access his name property, which should be the first property or the first parameter fed into the constructor. So let's see if that is working well. Console log. This is just going to be surgeon Romero. Oh, surgeon Romero dot name, but it's going to be dot. We can do this two ways. We can either have it be the getter that we're referencing or just the property itself. I'm going to try the getter and see if they, yeah. You could also do it where you do an underscore and that's accessing the property directly, but we want to do it where we're accessing our getters and then that's giving us the name. So then we call take vacation days on surgeon Romero with an input of 3. Just give us some more space here. So surgeon Romero, I'm going to have a method call here of take vacation days. And we're going to say he takes 3 days off. He takes a long weekend. How about that? Okay, and now we want to console log the value of that. By accessing the other getter. So surgeon Romero dot remaining vacation days. Put that R in there, and there we go. So he took 3 days off, and then this method ran, subtracted the days off from the remaining vacation days, which gave us a total of 17 days remaining. All right, moving on to inheritance. Now we're going to create some child classes, some parent and child classes. So imagine going back to our doggy daycare. Our doggy daycare is so successful that we decided to expand the business to open a kitty daycare. Before the daycare opens, we need to create a cat class so we can quickly generate cat instances. We know that the properties in our cat class, name, behavior, are similar to the properties in our dog class, though there will be some differences because, of course, cats are not dogs. Let's say that our cat class looks like this. So they set up a class of cat with a constructor that has a property of name, but instead of behavior, they add in a uses litter property. This then has the same properties as our dog, except it also uses litter. And they have all their getters set up, and then same method as before. So let's see. Okay, so in the example above, they explain that. And they say when multiple classes share properties or methods, they become candidates for inheritance, a tool developers use to decrease the amount of code they need to write. With inheritance, you can create a parent class, also known as a superclass, with properties and methods that multiple child classes, also known as subclasses, share. The child classes inherit the properties and methods from their parent class. Let's abstract the shared properties and methods from our cat and dog classes into a parent class called animal. Okay, so they create their parent class called animal. They have the two properties that both of the child classes are going to share, and then the getters and method that they're also going to share. So in the example above, the animal class contains the properties and methods that the cat and dog classes share. The diagram to the right shows the relationships we want to create between those three classes. So over here, they show us very simply that the properties that the parent class has, name and behavior, are inherited by the child classes, But with the child class for the cats, they also add one called uses litter. And then down here they just say that faded properties are the methods that are inherited from the parent class. So the methods are also inherited, and underneath that too, you could put the getters. Those are also inherited. All right, so then in the last exercise, we created a parent class named animal for two classes named cat and dog. So then they're giving us that again. And we will put this into practice, not doing the animal hospital, but a human one, a hospital employee. All right, so in the next few exercises, you'll create two subclasses, doctor and nurse, from a parent class named hospital employee. Below, we have listed the properties and methods you will find in the doctor and nurse class. Okay, so the doctor is going to have name, remaining vacation days, and insurance. And then he's going to have a take vacation days method. Nurse is going to have name, remaining vacation days, but instead of insurance, she's going to, or he or she is going to have certifications. Methods will also be take vacation days, but then there's going to be an add certification. In the main.js, create a parent class named hospital employee and add a constructor with name as an argument. All right, simple things. First class, this is going to be hospital employee. And then inside this, we're going to add a constructor with a name argument. So just type in constructor with name. All right. Inside of this, set the instance's name to name and remaining vacation days to 20. So this dot underscore name equals name, and then this dot underscore remaining vacation days equals 20. So this is basically going a step above what we did before, right? Creating one step of hierarchy outside of the surgeons that we were creating before. All right, under the constructor, create getters for your name and remaining vacation days. Okay. So let's do that here. Get name, and then return this dot name, this dot underscore name. And then our second getter will be get remaining vacation days. And then this one will have return, and this dot underscore remaining vacation days. Okay. Under the getters, add a method called take vacation days. So it should accept the one argument. Yep. So all of this is so far the same that we've done before. We're just recreating our parent class and naming something different. We had surgeon up here at the beginning, and now we are doing hospital employee. So the last thing we'll do is do the remaining vacation days method. And then this dot underscore remaining vacation days minus equals days off. And then we'll add that as a property, or sorry, as a parameter to the method days off. Oh, hold on. Minus equals days off, remaining vacation days, this dot underscore remaining vacation days. Remaining vacation days minus equals days off. Making sure that all the spelling is correct. The syntax looks okay. Let's check this again. Yeah, there's 5 times reference there. It's dot underscore. So did you create a method called take vacation days? Oh, take vacation days, not remaining. take. They want this one to be named take. There we go. All right, so we have our parent class set up, and now we will begin with the subclasses. So in this exercise, you will begin to create the nurse class as a child of the hospital employee. Remember, the nurse class has the following properties and methods. So the nurse has name, remaining vacation days, and certifications. So under hospital employee, create an empty class named nurse that extends hospital employee. So with this, let's take a look at the examples here, because they added one more keyword that we need to pay attention to. So once we've created our parent class, then since we have the shared properties and methods in the parent class, we can extend them to the subclass cat. So in their example, they're doing the animal parent class, and they set up their constructor with two properties, name and behavior. Underneath here, what they do is they call the cat class, but this is the new subclass that extends, and this is the keyword. This is the new keyword, extends animal, the parent class, and then has a new constructor. The constructor has name and uses litter as parameters. Inside of this is also new, the super name, and they'll explain that in a moment. But then the this dot underscore uses litter is going to be unique to this cat class. So in the example above, we create a new class named cat that extends the animal class. Let's pay special attention to our new keywords extends and super. The extends keyword makes the methods of the animal class available inside the cat class. The constructor, called when you create a new cat object, accepts two arguments, name and uses litter. The super keyword calls the constructor of the parent class. In this case, super name passes the name argument of cat into the constructor of the animal class. When the animal constructor runs, it sets this underscore name for new cat instances. So uses litter is a new property that is unique to the cat class, so we can set that in the cat constructor. So the things that are changing, right? Since we know that this is going to inherit, that the subclass is going to inherit these two properties. For one of those properties, we want to change it based off of what we input for our new cat, right? So in order to access that, in order to run that code, then we need to say super, which says don't use, or basically pass by reference, use this name that we're putting in through this class into its parent class, and then run the code for that. So then you'd have the name, whatever you set for the cat's name, run through the parent constructor, and that would give you a new name property. The behavior property isn't changing, so they didn't even list that as one of the parameters of the constructor, because we don't want that to change. We want that to still equal 0, so it will automatically, unless we change something within our new class, within the subclass. The thing that is unique, we did add in there for the uses litter. All right, so we call the super on the first line of our constructor and then set the litter property on the second line. In a constructor, you must always call the super method before you can use the this keyword. If you do not, JavaScript will throw a reference error. To avoid reference errors, it is best practice to call super on the first line of the subclass constructors. So basically saying that this keyword here has no reference because it's just a subclass. This needs to have a reference to the parent class, and the only way that connection is established is by using the super first. So then below, we can create a new cat instance and call its name with the same syntax as we did with the dog class. So you can say, just declare a new cat variable, give him the name of Bryce, and then the second argument, which is if he uses the litter, is false. So then you console log Bryce cat name, and it would output Bryce. And then if you console log Bryce cat underscore uses litter, it would give you false. All right, so let's try to implement this with our hospital employees. So in this exercise, you will begin to create the nurse class as a child. First thing we need to do under our hospital employee, create an empty class named nurse that extends hospital employee. So type in our keyword class, then say nurse. This is going to extend, so extends the hospital employee class. And if you remember from our game devs, we've seen this with the phaser games. Usually it's like class of something extends phaser game. So class nurse extends hospital employee. I think that's all they needed, just an empty subclass there. Inside the nurse class, create a constructor that accepts 2 arguments. Use the list of properties above to name these arguments. Check the hint if you need help. Okay, so constructor. So for these arguments, we're going to use the ones that are, or at least the one that is uncommon to these 2, right? We want to add in certifications there. However, we also want to change another one. So the ones that we want to change, we also have to list. In here, we want to change the name. So we're going to add in a name property or a name parameter, and then remaining vacation days. Wait, sorry, certifications. Certifications. So then those 2 will be passed in here for our constructor. Inside that constructor, we'll call the parents constructor method and pass the appropriate values in. So with this, we need our super name, and that will also establish what this refers to. Then this dot underscore certifications equals the certifications parameter that we have set for this class. And another way to think about this is, since it's creating an object, it's creating an object through the parent class. It's then adding a new property to that object. If it doesn't know where that object is, then it doesn't know where to add the property. So that's why you just need the super first to establish what this is, that this is the object you are creating, and then to add in a new property. All right, inside of the nurse constructor and under super, set certifications. Okay, so we did that too. We did that in one step. All right, so then under that class, create a new instance of the nurse and save it to a constant variable named nurse Olenek. Pass in the following values for each property. All right, so then we want to do constant nurse Olenek. Okay, that will equal a new nurse with Olenek as the name, and then 2 certifications. This is going to be an array, trauma, and pediatrics. Let's try that again, pediatrics. All right. Now that we know how to create an object that inherits properties from a parent class, let's turn our attention to methods. So when we call the extends in a class declaration, all of the parent methods are available to the child class. Okay, so to give an example here, we kind of went through this already. This is somewhat repeat information there, and then they're just calling that method on the class. Okay, so let's call the take vacation days method we added before on our nurse and give her 5 vacation days. So we've got our instance created. This is going to, if we work backwards here, this is going to run through the nurse class. This name is going to be passed through the constructor here, which is then passed through the constructor of the parent class. certifications is just going to be passed through here and then created as a new property. Now let's call the method on our nurse. So nurse Olinik dot take vacation days. We're going to give her 5 vacation days. She took a week off, like so, and then under that we're going to log the value saved there. So we want to access the property of our nurse Olinik remaining vacation days. And once again, this is just accessing the getter, not the property itself, or not the property directly. All right, 15. So yep, she took 5 days off, so now she has 15 left over. So in addition to inherited features, child classes can contain their own properties: getters, setters, and methods. Below, we will add the uses litter getter. The syntax for creating getters, setters, and methods is the same as it is for any other class. So in the example above, the uses litter getter gets in the let me try that again. Getter in the cat class that returns the value saved to uses litter. Compare the cat class to the one we created without inheritance. So this is all we need for a subclass that is using inheritance. If we didn't use inheritance, then we would have to type literally everything we had in the parent class again every time we created a new subclass. Might as well not have a parent class at that point, right? But that way, if you're creating like a pet store that has all sorts of animals, you can definitely benefit from creating a parent class and then only having a few lines versus several for each subclass. So we're still looking at the same way to call the supers. Okay, so let's use the properties and methods below to help complete the tasks that follow. Under the nurse's constructor, add a getter that returns the value saved to the nurse's instance certifications. So this is going to be unique to the nurse class. So we want to add in a getter here. Get certifications. Very simply return underscore this that underscore certifications. Okay. Certifications. Get certifications. Return this dot get certifications. Oh, there we go. Add a method called add certification under the certifications getter. The method should accept one input, new certification. Inside the method, use the push method to add the new certification to the value of the certifications array. So underneath our getter here, we'll put in add certification and then we're going to give it an argument of, or an input, right? Parameter, whatever you'd like to call it. We're going to add it in here, new certification, and then use the push method on the certifications array. So this dot, I guess this would also be, yeah, this would also be underscore, right? So underscore certifications, because that is the array. Then dot push, and add in the new certification to that array. But add certification that accepts an argument named new certification. There we go. At the bottom of main.js, call the add certification method on nurse Olinik with the parameters of genetics. So she's going to get a new certification here. She just went through some genetics classes, learned about the genome. So we're going to add in a new parameter for her. All we got to do is call the nurse Olenek dot add certification. And then a parameter of genetics. Genetics argument here that'll pass in through the new certification parameter and then be pushed to our array. I keep missing those. I keep switching those. The T and the I there. There we go. Keep spelling that wrong. Okay, so now let's log the value. Console log our array from nurse Olenek. Certifications. And once again, just accessing our getter there. And that gives us the array of trauma, pediatrics, and genetics with our new certification added right in. Cool, cool. Up next, static methods. Sometimes you will want a class to have methods that aren't available in individual instances, but that you can call directly from the class. Take the date class, for example. You can both create date instances to represent whatever date you want, called static methods, like date.now, which returns the current date directly from the class. The .now method is static, so that you can call it directly from the class, but not from an instance of the class. Let's see how to use a static keyword to create a static method called generateName in our animal class. Okay, so underneath this we have static keyword, then generateName, then a series of names within an array, and then we select a random name from that array. Okay, so then when you generate that name, it'll return a name. But when you try to use that on a subclass, it doesn't work. So if you create a new animal with the name of Tyson and you're trying to generate his name, it doesn't work for, well, the reason because the property on this subclass does not exist. So you can use your super to affix the name, the new name that you have as the name of the animal, but you can't use the static method. This is it only has the scope of the parent class. Okay, so inside of our hospital employee class, create a static method called generatePassword. When it's called, it should return a random integer between 0 and 10,000. So create a static method inside of the hospital employees. So our parent function here, our parent class, let us add this at the bottom. So static, add in that static keyword, and then have generatePassword. So it's going to return a random integer between 0 and 1,000, which, even though it says return, you don't have to explicitly state return. You only need to do that with the getters. So it's going to be math, or wait, maybe you do if it's just going to be a number. Yeah, you do need to do it in this case. You don't need to do it when there's a variable changing, like we did with the days off one, because that is returning the value through the operation by setting it to the property. With this one, since it's just it creates a random number and then doesn't do anything with it, we do need to return it so it has the scope of the class and it's not just stuck in the method. So let's use our random integer. So math.floor, math.random times 10,000. Okay. Cool. Okay, so this is a static method. So we can generate a password if we call it on the hospital employee. So if we try down here, if we try to console log that, console log the hospital employee dot generate password, and then it should give us a random number between 0 and 10,000. There we go. We can run that a few times and see that it's working properly. Wonderful. But if we tried this on, say, our nurse Olenek, it would throw a reference error because it's not accessible. It's outside of the scope. All right. So, way to go. Let's review what you've just learned. That was pretty quick. Not too shabby at all. Pretty easy lesson today. We'll go on and do a project with our knowledge of inheritance, but rather simple so far. So classes are templates for objects. JavaScript calls a constructor method. It's really just like, it's all the jargon, the vocabulary that you need to learn for this, but the logic of it is pretty simple. So JavaScript calls a constructor method when we create a new instance of a class. Inheritance is when we create a parent class with properties and methods that we can extend to child classes. We use the extends keyword to create a subclass. The super keyword calls the constructor of a parent class and must be placed on the first line of the constructor. Static methods are called on the class, but not on the instances of the class. In completing this lesson, you've taken one step closer to writing efficient production-level JavaScript. Good luck as you continue to develop your skills and move into intermediate-level concepts. Cool. So if we want to practice this some more, let's take some time to create a doctor class that inherits from hospital employee. All right, let's go ahead and practice that. They did show us this at the beginning, and then we never actually implemented it. So let's go ahead and do that. So let's do it underneath our nurse class, but above all the instances of that. All right, so we want to create a doctor class. Class doctor extends hospital employee constructor this is going to have a name because we want to change that. I'll skip remaining vacation days because that'll be the same as before. It's set to 20. If this was different, if he only had 15 vacation days, we would set it here within the subclass constructor, but we're going to keep it the same, so we can skip that one and then go to insurance as our second parameter for the constructor. The method is going to be take vacation days, but that is the same as the parent class. So within this, we want to say this dot underscore name, or not that. With the name, we want to do the super, right? So super name, and then this dot underscore insurance equals insurance. And then we don't need any methods because he doesn't have anything, like unless we wanted to say insurance, right? So maybe say get insurance, this value, this would return the insurance value. And then add a method here of like add insurance or add insurance provider. So add insurance and this would then, just like our new certifications method for the nurse, we want to push it to the array. So this dot insurance dot push, and then have it be the new insurance. In order to do that, we need to have it as a parameter. So insurance here, and then new insurance there. I think that would work. That would access the getter, right? Because this is not underscore, but it's going to push it through the getter and then add it to the array. All right, so let's test that out. So let's create a new doctor. So constant, just call him like Dr. Dr. Crusher equals new doctor, and have it be have the name be Crusher, and then an array of the insurance providers. I don't know, AARP, AIG. These both need to be strings if we're going to set them as those elements of the array there. Okay, and then from there, we'll go ahead and try to add a new insurance on the doctor. So the doctor is going to pick up a new insurance provider. Add insurance, calling that method on the doctor, and then add a string of, say, Geico. Might not be medical insurance, but you know what? It's insurance. We're going to add that in. And then we're going to console log the insurance that we added, or the whole insurance array. So just Dr. Crusher dot insurance. Okay, let's see what that does. All right, so add insurance is not a function. Let us see. Insurance, that's why. There we go. So yeah, so that passes through just fine. It takes the new insurance we added and adds it to that array with this method. Cool. So now we had it with the nurse, and then we created one ourselves without any instructions. Created a new doctor subclass. Cool. So next we will jump into a project with this information. And we'll be creating a school catalog. All right, let's put your knowledge of classes to the test by creating a digital school catalog for the New York City Department of Education. The Department of Education wants the catalog to hold quick reference material for each school in the city. We need to create classes for primary and high schools because these classes share properties and methods. Each will inherit from a parent school class. Our parent and 3 child classes have the following properties: getters, setters, and methods. All right, so we have the school parent property, or parent class, the properties of name, level, which the level will be primary, middle, or high, and number of students. All the properties have getters here. Setters, the number of students property has a setter. Methods, quick facts, and pick substitute teacher, which is a static method. So then the primary will include everything in the school class plus 1 additional property, pickup policy. The middle does not include any additional properties or methods. That'll be easy. Just constructor, super, done, right? Or I don't think you even need a super there because you're not changing anything. So you just put the constructor in and then you're done. High includes everything in the school class plus 1 additional property. Properties, sports teams, which is an array of strings. If you're looking for a challenge, create the constructor and getters for the 4 classes above. Then use the setter and method specifications in steps 5, 6, and 7 to finish the project. Okay, we'll take on that challenge. So create the constructor and getters for the 4 classes above. All right, so we'll go ahead and try this. Try this without any other further input besides what they need to say here. I might need some help with, well, at least the understanding of why we need a setter for the number of students. They didn't go over that in the class hierarchy. but the syntax of it is simple, just like a getter. So we'll go ahead and start with that class school. That'll be our parent class. Inside of here, we will do a constructor. This is going to have 3 arguments: name, level, and primary. Or sorry, not name, level, and primary. Name, level, and number of students. Primary is one of the possible levels. Number of students. All right. Then for these properties, we'll say this dot underscore name equals name. This dot underscore level equals level. And this dot underscore number of students equals number of students. Okay. Outside of this, we're going to add in all of our getters. And if you want to skip ahead this part or just do it on your own and then skip ahead, it's pretty simple. We're going to do a get name. This dot underscore name needs to be returned. What I'm going to do here is literally just copy this down, copy the structure of it down a couple times, and then we'll change the specifics. Ooh, let's add that G back in there. The next one is going to be level. And the third one is going to be number of students. Okay, so I have our getters in place. Then we have one setter for the number of students property. So set number of students property. And then just, I think it's the same. We don't have to return anything. We're just setting this dot number of students. Is this equal to anything? I don't know if this is equal to anything, unless it's like equal to whatever argument is put in through here. So just like num. Can you put that in there? I forget. Yeah. Okay, we'll take a look at that in the instructions. This is a mystery to me at this point, what this would be used. I mean, it's going to be used to set the number of students, but like how it's used, I'm not sure. If it's going to be equal to like a parameter within the setter, I think it would be. But we'll go ahead and keep that in a comment just for now. Then add in the methods of quickfacts and pick substitute teacher. So quickfacts. They don't tell us what to put into the method yet, so we're just going to have that method empty. And then pick. Let me bring this up a little bit. Pick substitute teacher. Okay, this is going to be a static method, the substitute teacher one. I'm guessing it's going to be like random. It returns a random number, and then based on that random number, it chooses from an array to pick a substitute teacher. All right, also we have, let's see, so level is going to be one of 3 strings. So the level array, I guess this could be, we're not going to pass this through. This is equal to an array. So at the top, we're going to change this to be primary, middle, and high. Okay. And then to like set the level, we might need another method for that. I'm not sure. They didn't tell us to add one, but we need it to set the level for the certain school, right? I mean, another way to do this is just set it to be like this level equals the level, and then later you just type in manually the type of school that it is, and then it would be set to that's what the level is. So set up the string in the subclasses, and then it would just pass through as the level. But we're going to set it this way, see if there's a way to like access those without manually stating it. Okay, so that's basically all we can do for our parent class so far, because they haven't told us what to put inside of the methods. So now we're going to add our subclasses, and start with primary. So primary includes everything in the school class plus the pickup policy. So we'll type in class primary. This is going to extend, so extends the school class. Put in our constructor. This is going to have, let's see it. It needs to have an argument of name because we want to change that. And then pickup policy. Not sure what to do with the level yet because we want it to be primary, right? Like I said, you could do it, the more direct way is just to have this equal to level, and then down here to say within the level have it just equal primary. But I feel like there's another way to do that that doesn't have you state it directly. But we'll see as they walk us through what that is. Anyway, so this dot underscore, nope, we need the super first. Super name to pass that through, and then have this dot underscore pickup policy. And have that equal pickup policy. Okay. And that should be all we need for the primary school. Middle school does not have any additional properties or methods. So class middle extends school. Constructor name, and that's it. And this is just going to be a super name. All right, and then our high school, it includes everything except a sports teams. It has one additional property of sports teams, which is an array. So class high extends school. Constructor name, and then sports teams. Super name, and this dot underscore sports teams equals sports teams, which Yeah, which we're going to pass through as an array of strings. That would be in the instance we'll pass through the array. Sports teams, like so. Class middle extends school. Do we need... Wait a second. What's up with that? It doesn't mind the primary school, but it doesn't like the middle school. Class middle, unexpected identifier. Do you need a semicolon here? No. Very strange, very strange. Class high, it doesn't like the high school either. Doesn't mind the primary, I don't think. Let's get rid of these, see what it does with that. Yeah, it doesn't mind the primary. Oh, I see. Because this brace needs to be on the other side. Just a syntax error on my part. There we go. Now we don't have a reference error. So let's see. The only like variable... Well, there's two things. The one is the setter. I'm not sure what we're doing with that. The other one is the level. Let me add in the one way of doing it first, so we have a little more functionality, and then we can add in the array if we need to. So this is just going to equal level. When we pass through the supers, we're going to add in another parameter to each of these, and then just say that the level is going to equal the level that we pass through. But yeah, like I said, there might be a more efficient way of doing that, which we will discover in a moment, but this is one way. So in each of our instances, when we pass in the level property, primary, middle, or high school, it'll go all the way through the parent class. Okay, let's start this then. See how much we got through on our own. So let's start by making a parent class for primary, middle, and high classes, and an empty class named school. We did that. Inside the school class, empty constructor, yep. Accepts 3 parameters, Inside the constructor, set the school properties and prepend all of the properties with an underscore. Create getters for those 3 properties. Create setter for number of students. Okay, so this one, I need to pay attention to this one. The method should first check if the input of number of students is a number. Okay, so if new number of students is a number. Okay, yeah. So there does need to be a parameter here, and it's going to check if this parameter is a number. So whatever's passed through. I think a setter always needs some sort of parameter, or else it won't set anything, right? Because it needs that scope. Number of students. New number of students. If this is a number, so if this is equal to 3 equal signs and then just the word number, although no, that's not how you do it. It's new number of students dot type of, right? Isn't that the method you use to see, or the property that you reference? We'll check on this. I think type of is what you use to say what type of data is this value, whatever we're passing through the setter here. Oh, I just realized I am editing the getter and not the setter. Okay, because we commented that out and I was simply looking at the new number of students. So let's move this down. Let's get rid of this. Leave the getter the way it is. Ignore what I just did. And we're going to put in here new number of students and reactivate the setter here. And honestly, the parameter, since the name of it doesn't matter that much, we're just going to put in num and then just put in num. Make that a little bit smaller. Okay, so if this is correct, I don't know if this is a method call or if it's like just a property of the thing, but we're going to do type of and then number. And then if it is a number, set the number of students property So this dot underscore number of students equals number, or just num as we have. And then if not, this will be contained within a code block here. Well, let's get rid of some of those. And just make this a little bit tidier. There we are. Then if not, else, we'll return a string and console log invalid input. Invalid input. Number of students must be set to a number. Okay. Okay, no reference errors, so I think that's correct. We'll see once the setter runs if type of is just a property. I think it is, because there's the length property and the, what else? Like, I guess I just know those two that are like a global properties you can access for any data type. All right, so under your getters, I create a method named QuickFacts, okay, that logs the following string to the console. School name educates number of students at the school level. Okay. And instances name value. Okay, so let's go ahead and add this to QuickFacts. So console log. We're going to have backticks here because we're going to be interpolating some variables. The first one is going to be the school name. So in place of that, we need to substitute an instance's name value. In this case, we can just access the this.name. So let's do that first. So $, braces this._name. Yeah, and this still has scope here. So that'll still work, just like it did with the getters and the setters. So this ._name educates, and then we're going to add another variable, number of students. So this _number of students. I suppose you could also do this where you just access the getters like that, and you don't have to access the properties directly. We can try that. This.name, this.number of students. Then have students at the final variable, this.level, school level. Okay, so this should say that, say we have the primary school, right? It has like 500 students. When we access the getters, it should say, so the primary school educates 500 students at the primary level, right? So under this, create a static method named pickSubstituteTeacher. This method will receive one parameter, substitute teachers. I'm just going to put in subs. The parameter will take an array of strings. So inside the method, generate a whole number between 0 and 1 less than the length of the substitute teacher's array. Between 0 and 1 less than the length of the substitute teacher's array. Okay. Use this number to access and return the substitute teacher at that randomly generated index. All right, so first we want to generate the whole number and return the substitute teacher at that index. So what are we setting this equal to? Are we setting this equal to a new property? We'll take an array of strings. All right, well, let's write out our integer, a randomized integer first. So floor, math.floor, math.random. This is going to be multiplied by the length, or 1 less than the length of the substitute teacher's array. So subs.length minus 1. And I think these might need to be in parentheses, just because of the order of operations there. The parentheses need to resolve first. So the length of the array minus 1 times a random value between 0 and 1. Okay, so that's what we need for our random generator. To access and return a substitute teacher at a randomly generated index. So, okay. I'm thinking of this in a different way. I'm thinking of this like you access the subs within, like, so you want to access the index of, yeah, so whatever is here, right? That generates what's at that index, or an index number. And then so when you call that, it'll say what is at index 3. And this will produce a randomly generated index within the subs array. But the subs is an array of itself, right? I think, so that would work. It would reference the array, pass through a random integer that would become the index. So now what are we setting this equal to, though? What are we setting this equal to? Oh, like substitute teacher, I guess? Like just, yeah, like just create a new property then? I don't know. It's kind of weird. They didn't tell us like what it's being set equal to, but we can go ahead and put that in. So this, so pick substitute teacher equals randomly generated index of subs. And this can just be like substitute teacher. Okay. Simple enough. Create a primary school class. So next we'll build primary school that extends school. If you feel comfortable building the primary school class on your own, give it a shot. Whether you want to follow the steps or not, it's important to note that the class has only one additional property. Okay, so inside of the primary school class, create a constructor that accepts 3 arguments. Okay, so maybe we might have been onto something with it. We needed the level. Because why would it need 3 arguments if it only has 1 extra property? So I think we're on track with that. Call the super on the first line, pass in any arguments the parent constructor uses. Since this is the primary school class, primary as the argument for the level parameter in the parent constructor. Okay, so this actually needs to be I think we can do it this way, where inside of the super we can put in primary. Let's see if that works. Use the remaining argument to set the pickup policy that the parent constructor uses. Yes, okay. Pass primary as the argument for a level parameter in the parent constructor. Okay, so I need to know all of the links in the chain here. So level, when it goes with super, it's going to say whatever is set to this instance, it's going to pass through the parent, right? And then set the name to that. It's going to do the same thing with the level. However, where does the level get set? Does this need to be primary? This is going to accept something from the instance, right? For the level parameter in the parent constructor. Yeah, I think that's fine. I think we have it in the right place. Because this would say that it's going to, like, whatever the value is in the second place parameter for the instance we create. So we create 5 different primary schools. Their second parameter is always going to be primary. But in this case, we just want to set it that way here so we don't have to type that out every time. But then I don't know what would go in like the level slot. Okay, we'll unravel that here soon. All right, then we use the pickup policy property. And since it inherits the school properties, we only need to create one new getter for the primary school class. Oh yeah, I forgot to put in the getter for this. So get pickup policy and this dot underscore pickup policy. I'm still thinking about that level thing. Because we do have a getter that returns the level. I guess we could do it this way too, where we just say, let's see if this works, but I think this is a little more reliable if we just say level, and then this dot underscore level equals level, or equals primary, sorry. Equals primary, right? I'm curious if the other way works, but I think this is more reliable. So it's literally stating that set the level to primary, right? And that way when we create an instance, we can just type out level, or just like an empty string that turns into primary. Okay. So we need to return this as well. Return this dot pickup policy. And then we create a high school class. I also need to add in a getter here. I forgot about that. So we need to get sports teams. So this is going to return this dot underscore sports teams. Like so. Okay. So the getter should log all of the sports to the console. Okay. So not just return, but we want to console log this. The whole array. And we might need to, because nothing happens unless we return the value from the getter, right? So we have to return the console log of this .sports teams. I think that will work. Check out the hint if that gives us some trouble. All right, so then instances of the primary and high school. Did we not create a middle school class? I guess not. I guess they just skipped that one because there wasn't much to do there. Lorraine. Okay. Well, one thing that we might have to do with this one is set this dot underscore level to middle. Once again, I don't know that that's necessary, but we will put it in just in case. And this one's going to be high. High school. Okay. So instances of primary and high school. Create primary school instance with the following properties. So the name, number of students, and pickup policy. Save the instance to a constant variable named Lorraine. Oh, okay. Wait a second. Yeah, hold on. I didn't think about the number of students. The number of students is going to be changing. So actually the level is not going to act as the super there. I'm not going to pass in that. We're going to pass in the number of students. I totally forgot about that. Okay, so number of students, and we have to put this into each of our schools or each of our subclasses, and then this will be within the super. Yeah, okay. I think in that case, that clears this up where it does need to be stated directly, like the level equals primary. Yeah. Yeah, I think that'll work because then it will inherit that property, and then we can change that property. Then here we need that as well, the number of students. Number of students. And same thing with the high school. There we go. Yeah. So then the only thing that's unique with that is the pickup policy and then the sports teams for the high school. All right, now we can create our instances. So class, or not class, we need to do constant Lorraine Hansberry. Hansberry equals new primary with the arguments or the properties of her name, Lorraine Hansberry, the number of students, which is 514, and then the pickup policy, which is students must be picked up by a parent, guardian, or a family member over the age of 13. I'm just going to copy that over. This will be fed into our pickup policy. There we go. Okay. So then call quickfacts on the Lorraine Hansberry instance. Let's do that here. Lorraine Hansberry dot quickfacts. And so then the principal of Lorraine Hansberry needs a substitute teacher. Hold on. Quick facts. Oh, yes, this needs to be capitalized. There we go. Hey, it worked. Lorraine Hansberry educates undefined students at the primary school. Oh my goodness. Okay, hold on. What happened here? Undefined students. All right, so the number of students. Okay, what happened? Where is this? Oh. Oh, this is interesting. Okay, so this dot number of students. So our two getters worked. Also, yeah, the links were all connected for the level too. So this added a new level property, and then it was assigned to be in the parent as the level property here. and then we were able to return that with a getter. So those two are working. And now we just need to see what's wrong with the number of students one. Number of students, make sure that this is spelled correctly here. Number of students, yes. So the super is passing through that number to this class through this super. This then becomes number of students, right? Or do we need like, yeah, that should work, right? Should work. And then check to see if the number of students is a number. Then you return that number to the number of students. Now, if we put a different, let's see if our setter is working. So if we put a string in here, we make that a string instead. It still returns undefined. So let's go back up to our setter instructions and see what we can fix there. Oh, and we also have to log that too, so we need to log the message. Yeah, we are logging that message. So I don't think, maybe the typo is wrong. If type of, let me check on the documentation for that. JavaScript, it's the MDN. So this is, we're looking for like the type of, right? Type of operator. Oh, okay. Okay, it's an operator, so it doesn't, yeah, it doesn't work like a property or a method. That's what's going on. So the setter is not, doesn't have proper syntax. We need to add this into here. Type of num. Is it just, it's not camel case, it's just all lowercase. Type of, there we go. Now what happens? Okay, so it's still undefined, but let's change this back to a regular number. Try that again. Okay, it's still undefined. Still undefined. Number of students equals num. Okay, well, let's see what the next steps are, because we haven't actually set that yet. Yeah, see, I don't know why the setter is necessary, because we have a number here. It's going to be passed through our constructor at the top for number of students. Name, number of students. My only thought is that number of students in our primary class is being passed through as level because it's in the second position. But it shouldn't be, because it's just number of students here is set to whatever this value is. But maybe that's the case, so let's change, let's not do the super for both of these, and let's just say this dot underscore number of students, and see if that's where the issue lies. Number of students equals the number of students. Yeah, okay. That's really interesting. That's really interesting. Okay. I wonder if we can do it the other way too, where we have just like hold on. Let me copy that in and then delete this. Since it needs like a level placement, just put in level and then number of students. But then level is not defined because it's not up here. Oh, that's interesting. It puts the policy in place at, wait, what? Over the age of students at the primary school level. So Lauren has Hansberry educates students must be picked up by a parent, guardian, or family member over the age of 13 students at the primary school level. So that's putting in the policy as our number. Which is really strange, because then this number of students is becoming the pickup policy. Even though the super is passing through. Oh, because we have 3 arguments here. That's right, yeah. Okay, well, I'm going to switch back because I don't see a way to do that where we put everything into the super. So I'm just going to directly state that this number of students equals the number of students. Voila! We have 514 students at the primary school level. Woohoo! Now, we'll need to change that. We'll need to add this in for the other levels as well. And like so. Yeah, there we go. Okay. Now let's move on to step 16. The principal of Lauren Hansberry needs a substitute teacher for the day. Call the substitute teacher method on school and pass the following array as an argument. All right, so remember this one is a static method, so we can only use the parent class for it. So we'll just call that school.pick substitute teacher. Substitute teacher. And we're going to give it this array. Whoa. I could not copy that. Can I copy it now? Nope. I'll just have to type it in manually. Okay. That is fine. Jamal Crawford. Jamal Crawford. Then Lou Williams. Lou Williams. J.R. Smith. James Harden. If you haven't noticed by now, well, you probably won't notice. But for those that do, it's a little funny. Manu Ginobili. Okay, let's pass that totally random substitute teacher thing in. That should be associated with the sports teams, by the way, not the teachers. We'll pass that in as an array. And now if we call that, wait a second. Yeah, so then can we console log this? Console log, whoops, not that. Underneath this. Console log the this.substitute teachers. Substitute teachers. Or teacher. Yeah, there we go. And then that should change every time. Yep. Cool. Cool. we could also add in, like, this is complicating it further, but you could add the substitute teacher in as one of the constructor parameters, and then set set a property there. But that's kind of redundant because we're already creating a property here. So we create the property and then we console log substitute teacher after we set the array. All right, create a high school instance with the following properties. All right, so that's our primary school. Let's create the high school. Let's call it Al Smith. So constant Al Smith. This is Al Smith High School. Equals. This is going to be new school. Or no, this is going to be new high. And then have the name set to Al E. Smith. Al E. Smith. Number of students is 415. Sports teams is this array. Baseball, basketball, volleyball, and track and field. All right. Get the value of sports teams property in Al Smith. So Al Smith High School dot sports teams. Okay, but it didn't console log that. We need to console log the sports teams in the parent class. Or sorry, not the parent class, in the subclass. So it returned that value but didn't actually console log it. So let's get rid of that return. Still didn't do anything. I think it needs to return it first and then console log. So let's shift this down to the second line and return this underscore sports teams. And then with our getter, yeah, it should access that property. Nope, it's still not doing it. Just underscore sports teams. Did I call the right one? Oh, sport teams. I need sports teams. Let's see what that does. Nothing? Okay, so maybe it was right. I just had it spelled incorrectly in the reference. There we go. Yeah. So that was the right syntax for that. You return, and then you return the console log. So yeah, then we have all of our sports teams there. Everything seems to be working properly. So nice work. If you made it this far, you have a strong understanding of class syntax and inheritance. If you'd like to continue working on this project, we have listed some avenues to build your progress. Create a middle school class. We did that. Yes, indeed. Created the middle school class here. Add more properties to each class. Thank you for the follow. Average test scores, school overview, etc. Create a class called school catalog that holds a collection of schools. Create an instance of school catalog for primary, middle, and high schools. Okay, so that holds the collection of schools. Create an instance of that for primary, middle, and high schools. All right, so this last one here is basically just like, it's essentially just renaming the top one. Create an instance of school catalog for primary, middle, and high schools. Oh, I see. So this would be like an extra layer underneath school. So we would have school and then school catalog. And then we'd have a bunch of like school catalog primary. No, it wouldn't be like that. This would basically just be renaming this. School catalog, there we go. We did that one. Of course, then it breaks everything because everything's a reference to that. But yeah, essentially that would be the parent of everything. And then you'd have different sections for your primary, middle, and high schools. Creating more properties for that. I think we've done that sufficiently. We've created arrays. We've created just string objects. We've created references to methods. So I think we've conquered this pretty sufficiently. All right, let's start the quiz. What is the purpose of the constructor method? Each property has a constructor method. It is called whenever you try to get or set the property. The constructor is called when you create a new instance of a class. It sets property values for each instance. I guess that's technically correct, but I don't think that's what they're looking for. The constructor method is only used in subclasses. That's not true. Subclasses inherit the constructor from the parent class to set property values for the child class. Each property has a constructor method. I know what it does, but I think I'm just overthinking the wording here. So it's called when you create a new instance of a class. It is that, but that's not really that is part of the purpose. It's not the whole purpose. It sets the property value for each instance. Also, there can be other values that are set by the subclasses. Yeah, the constructor is used. Subclasses do inherit it from the parent class, but then they can also have their own unique properties. And each property has a constructor method. No, that's thinking of it backwards. So it would be between these two. I think it's this one because it's saying that that's the purpose where we wouldn't need a constructor method if we had just one class. Essentially, it would just be an object at that point. You wouldn't need a constructor at all. You would only create that if you wanted to create objects from that. But also, it is called when you create a new instance of a class and it sets the property values. Oh, it doesn't necessarily... I mean, it assigns property values, but you can then change those. Kind of 50-50 on those, I'm not sure. Values for each of the child classes. So how would I describe it? What is the purpose? So the purpose is to establish property values to be used by instances of that class. Okay, so I'm going to go with the bottom one. Yes, okay, cool. Yeah. I just had to think of how I would say it myself. Then we got it. Yeah, so it's called when you create a new instance. Because if you didn't have that, it would just be an object, and you wouldn't be creating objects from it. Okay, so how would you call the random.burrow method in the example? All right, let's look this over. So they've got a rental unit class with a constructor, get address, cost per year, calculate monthly, class apartment extends rental unit. Okay, so they're creating a subclass called apartment, and we're looking for the random burrow. So let's keep track of this. So they have two properties here and a method. Then when they add in their apartment class, then they have those two properties plus number of bedrooms. That's then added manually with another method or another getter. Static random burrow. So this static is within apartment. This then sets an array and gets a random index of that array. So then when you create an instance of a new apartment, you set... Yeah, so then you're going to call random burrow on my apartment, right? It would be my apartment random burrow, because that's the instance. And then that would have its scope, would have proper scope because it's a static method within that. Oh, right. No, it would be apartment because it's static within apartment, not within the instance, right? Okay, cool. What is the purpose of inheritance? To share data and methods between objects. To create new functions that have the same data and methods for other functions. To create functions that pass through the same parameters through a chain of functions. It's not between objects. It's not to create functions that pass through the same parameters through the chain of functions. To share data and methods between objects. Okay. Yeah. All right. I mean, I understand the purpose, but the wording, my understanding of the wording is lacking. All right, which of the following is the subclass in the example below? So the subclass here was the apartment, right? That's the capital apartment. Which of the following problems do classes alleviate? So classes inherit properties and methods from objects that make it easy to create objects with the same property values, but different property names. Yes. Classes make it easy to create multiple objects that share property names and methods. Yes. Classes make it easy to create multiple objects that share property names, but not methods. Objects make it easy to create multiple. It's not even saying like what classes do on the last one. So it's not the bottom two. Classes make it easy to create multiple objects that share property names and methods. Yes, this one. But here it's saying they inherit properties and methods from objects that make it easy to create objects with the same property values but different property names. Sort of, but in all of our examples, we haven't been naming them differently. You could name them differently. Because if you had like a parent class with a name, you could then have a subclass and then call it something else. Like you could literally name it anything, like strawberry, and then have that be passed by reference into the name. We never did that, but I think that's possible. But they don't necessarily inherit that share property names and methods. Yeah, I think it's the second one. Because that's the purpose of it, is like it's creating multiple instances of objects that have all the same property names and methods, and then you can change the specifics of what those are, but the property names don't change, right? Like we had underscore before all of our property names, and then the actual word or array that we were putting in changed, but not the properties themselves. Okay, so when you create a subclass using the extends keyword, what will the class inherit from its parent? The subclass inherits all of the parent's getters, setters, and methods. You can use the super keyword to set properties in the parent class. The subclass does not directly inherit anything. You must use the super keyword to set properties and inherit getter. No. The subclass inherits only the parent class getter, setter. The subclass inherits all parent properties. When you use the extend keyword, set the properties of the parent class. Yeah, it inherits all the getters, setters, and methods. It also inherits the... I guess, yeah, you do have to set the properties themselves explicitly, right? Because you have to say super and then set the properties inside of the parent class. So if we had one where we didn't use a super and we just said, yeah, I think it would have to be explicitly declared as the properties. Okay. Which of the following will create an instance of the rental unit class and save it to a variable called myRental? Rental unit constructor. This address equals address. This dot cost equals cost. Calculate monthly divided by 12. Okay, so which of the following will create an instance of rental unit and save it to a variable called myRental? So we need constant myRental and then new rental unit, but we need the properties there as well, right? So it'd be myRental rental unit with two properties, just address and cost. I believe so. but it needs to be new. So new rental unit, and then this. This would just, like, this wouldn't do anything. I don't think. It would just create like undefined properties. We would need to define those properties here. And then what this is asking is to save the values to my rental. So it's going to be new rental unit. Yeah. With 2 arguments. Which of the following keywords is required to create a new class? Classes. Which is the purpose of the super keyword? To call a parent constructor. Yes, indeed. Why will the code below throw an error? All right, let's check out what's wrong with this code, eh? Class rental unit has all of its getters and setters. They have the return in there. They have the properties inside of the constructor that's assigning properties to those parameters. The method looks fine. Syntax looks fine with all of that. Class apartment extends rental unit. Oh, this. Because it's like, it's declaring the rental unit as if it were an instance, right? Or no. No, that is correct. Yeah, okay. So rental unit. Constructor, what did they use here? They used this number of bedrooms. Because the super is on the wrong line, right? The super needs to be listed first. The super keyword must be called before the this is used. Yeah. All right, which of the following in the rental unit is a method of the rental unit class? Calculate monthly. Doop. All right, cool. I'm going to take that again. Try to get all of them correct. Do a refresher here. What is the purpose? Okay, so this is the one that tripped me up before. So hopefully I can actually get it right this time. I remember it was between these two. The constructor method is the only used in subclasses. The arguments are sent to the parent classes where this is not true. The constructor is called when you create a new instance of a class. It sets the property values for each instance. Each property has a constructor method. Okay, so these are not true. Subclasses inherit the constructor method from the parent class. To set property values for the child class. This is not true either. Oh no, wait. Did we say this? Yeah, because they inherit to set property values from the child class. Yes. I believe we decided on this one, yeah? No, it was, okay. Okay, yeah. I think I did decide that, but that was incorrect. Okay, I'm just gonna skip through, do random guesses, and then get to the. Wow. Okay, I got 2 right there. I'm literally not even looking. Okay, now I'm kind of looking. Let's just go through, choose all this, and restart the quiz. Okay. All right. So it's called when you create a new instance of the class, and it sets the property values for each instance. Yeah. Because the second time I was looking at it, I thought that this was correct, as I misremembered. But looking at it, it doesn't sound right, because if it inherits from the parent class, there's no need to declare a constructor for the subclasses. But we put in a new constructor for each subclass that we're creating. Every single time you declare a class, however far along you are in the hierarchy, it always it needs a constructor method, an individual constructor method. So this is correct, where it's called when you create a new instance of a class, and it sets the property values for each instance. And I think I didn't quite understand what it was, like how it was being called, because I was thinking like, oh, it's being called from the parent class, which doesn't sound right, but it's not. It's a method. It's a built-in method that you're calling to set the property values. Okay, this one was apartment random borough, right? Yeah, because that's the static method. This one is that it shares between objects. Oh. This is the subclass apartment classes alleviate. They make it easier to create multiple objects that share property names and methods. The inherit properties, yeah, it was... Oh, come on. I was like, oh yeah, it's the inherit properties one. No, it's make it easy so that they share property names and methods because they don't inherit everything. All right, we'll get there. We'll get there. We're going to go back to the beginning. We will get 100% on this quiz. Not that it matters. Comprehension matters. Comprehension matters far more. Okay, so the purpose of the constructor method. Not this one. It is when you create an instance of the class. Random burrow is going to, or how you call it is the apartment. This one is to share data. This one is this is the apartment. This one is the easy way to create multiple classes that share properties and methods. And then this one was like, so this has objects, first of all. That's not even part of the classes. Classes make it easy to share that, yes. It's not the inherit properties. And it's not this one because it says not methods. So it's the top one here. And so, yeah, each instance of the class has the same properties, getters, and setters, and methods, and only property values change. So property values, not the names. The keys for each property are exactly the same for all of them. Yeah. And it makes it streamlined that way. But the values of them are changing. So you could even have a property name called name, and the name is changing, but the property name of name is the same. So only the values change. All right, so when you create a subclass that it uses extends, this one was... Does it inherit all the parent properties? No. It inherits the... Yeah, so you can set the properties using this super. Okay. Rental unit, this was create an instance. We needed the 2 arguments plus the new keyword. This is class. The super keyword is used in subclasses to call parent constructor. Yes. In the code below, throw an error because the super was not on the right line. There we go. Rental unit class. The method was the calculate monthly. Okay, there we go. Sweet. Got through that quiz. Start next informational. We'll go ahead and wrap it up for today. Phaser animations. This is going to be fun. It's going to be fun. I haven't taken a look at these yet, so I'm excited. So jumping back into learning Phaser, we will learn, this will be tomorrow, the use of classes, animations, and tweens. Tweens, interesting. I remember that from an animation class, actually, the tweening in what were we using? I think we were using like a flash animation, like Adobe's old flash animation program. Welcome back to the world of Phaser. All right, so we will begin this next time, and that's the other half of this module, and then we only have one more module in this course, so we are moving right along. All right, well, in the meantime, everyone have a great day. I hope you enjoyed this and learned a little bit along the way. I'm learning a lot for sure. Live long and prosper, everyone. I will see you next time. Peace.